In the vast silence of space, even the smallest change can rewrite everything we think we know. 2 nights ago, something happened that sent shock waves through every major observatory on Earth. The interstellar object known as 3I Atlas, a mysterious traveler from beyond our solar system, suddenly brightened not gradually, but explosively. In just 6 minutes, its luminosity jumped by a factor of 4, a flash so fast and precise that amateur telescopes across continents caught it at the exact same moment. Mars orbiters burned fuel to reposition. The Deep Space Network abandoned ongoing missions, and the International Astronomical Union called an emergency session, the first in years. Scientists who once shared data freely suddenly went silent. Whatever was happening out there wasn't just another cometary outburst. It was something no one could explain, and it was happening right now. It began quietly, as all revolutions do. In a small town in Germany, amateur astronomer Maria Schultz noticed something off in her data while observing 3I Atlas through her 12-inch telescope. Her software flagged an anomaly, a sudden vertical leap in brightness, 1.4 magnitudes higher than before, sustained for 6 full minutes. At first, she assumed it was a glitch. But when she checked her calibration stars, her equipment, and even atmospheric data, everything was perfect. Within 30 minutes, observers in New Zealand, Arizona, and Brazil began posting identical results. The light curve was impossible, not sinusoidal, not periodic, just a flat line that suddenly jumped like a heartbeat and then held steady. No comet, asteroid, or fragment had ever behaved this way. By comparison, the legendary outburst of Comet 17P Holmes in 2007 took nearly 2 days to brighten by a similar magnitude. What Schultz saw happened in less than 1% of that time. By midnight, the Atlas anomaly was trending worldwide, and within hours, the global astronomy community was awake, staring at the same question. What could possibly cause such a clean, instantaneous burst of light? As word spread, a chain reaction swept across the globe. Forums and Discord servers filled with overlapping screenshots, exposure logs, and light curves, all matching down to the minute. Citizen science platforms like Skywatch Collective went into overdrive, confirming the anomaly across 4 continents. It wasn't a hoax, nor an equipment malfunction. By dawn in Europe, professional observatories were on alert. The Pan-SDARRS and Atlas Survey telescopes confirmed the spike, as did robotic telescopes operated in Chile and Japan. Data streamed into a growing public repository, a digital relay of humanity's curiosity. But then something strange happened. The professionals took over. The Deep Space Network interrupted routine Mars telemetry, rerouting its 70-meter dishes toward the coordinates of 3 Atlas. Engineers voted unanimously to override standard scheduling, sacrificing data from missions like Perseverance and Voyager to capture radar reflections from a single interstellar visitor. The decision cost them 22 hours of lost mission time, a move reserved only for life-threatening asteroid flybys. Yet this wasn't an impact threat. It was a light anomaly. And still, the world's most powerful antennas turned their gaze toward one point in the sky, as if every nation sensed that something extraordinary was unfolding above. The global coordination didn't stop there. By the following morning, the Very Large Telescope in Chile, Gemini North in Hawaii, and even China's Fast Radio Telescope had all dropped their planned targets, redirecting every instrument to 3I Atlas. The International Astronomical Union voted 8-2 in favor of a planetary-scale observing campaign, a rare act of unity in a field often divided by funding and competition. For 48 hours, humanity's finest instruments watched the same object. And then, silence. The same astronomers who had been posting hourly updates on social media suddenly disappeared. Private research chats went quiet. No new data appeared on preprint servers. No press statements, no leaks, nothing. Analysts tracking social media activity reported a 70% drop in communication from verified astronomers who had previously discussed the event. Something had changed behind closed doors. Even the few automated logs that trickled out painted an eerie picture. Radar signals showing a non-gravitational acceleration 4 times stronger than expected, an infrared plateau 30 Kelvin above normal, and faint bursts of gamma radiation at 3I Atlas's exact coordinates. None of it made sense, and yet all of it was real. Within 2 days, the anomaly had transformed into a full-scale mystery. The Mars orbiters confirmed the same infrared excess despite being millions of kilometers away. Ground-based telescopes recorded the same acceleration, and deep space antennas detected faint echoes that seemed to pulse at regular intervals. But the most haunting detail wasn't in the data, it was in the reaction. Astronomers who had spent their careers chasing comets and asteroids now refused interviews. Entire observatories were locked into silent mode, citing data verification. The IAU's internal report, leaked by an anonymous insider, described the situation as a synchronized global anomaly requiring immediate containment. No other words. No public explanation. Just a note that all assets are to maintain continuous observation until further notice. For the first time in modern history, every eye on Earth was focused on one object from another star system. An object that, in a matter of hours, had forced humanity to rewrite its definition of what's natural and what's not. The official statements were predictable, instrumental errors, solar interference, data reclassification. But behind closed doors, Project Helios, a task force formed by the International Asteroid Warning Network, concluded something that was never made public. The directed beam wasn't a random transmission. It was a response. When the first amateur telescopes detected the brightness anomaly weeks earlier, Earth had unknowingly emitted its own faint electromagnetic noise back into the cosmos. The flare from thousands of synchronized instruments, cell towers, satellites, and radar beams had bounced off the object. 3 Atlas hadn't simply appeared brighter, it had been illuminating us back. And now, silence. No pulse. No gamma spikes. No acceleration. The interstellar traveler drifts beyond Mars, silent and watchful. The data classified. The world moved on. But among the astronomers who first saw the 247-second rhythm, one question remains. What happens when that frequency returns? What if the next signal isn't light but something else? Because maybe 3 Atlas never came to visit, maybe it came to synchronize. So if this story made you question what's really happening out there, don't look away. Subscribe to this channel. We uncover what the rest of the world is too afraid to discuss. Turn on notifications, because when the signal returns, and it will return, you'll want to be here to hear it.